We released Research and Engineering Studio late last year, and it's been a hit. But before the paint even dried, customers were asking us how they could integrate ParallelCluster into it to submit jobs. If you think just running jobs isn't a terribly exciting experience, then consider what happens when you can spin up a visual desktop session in Res that is not just like a login node for submitting jobs on a ParallelCluster, but actually is a login node that's part of your ParallelCluster. You can load up that VDI session with all the visual apps you need to interact with all the tons of data your HPC jobs are generating. You can share that desktop with a collaborator in real time and figure out the answer to that problem you've been trying to solve together. Now, linking Res and ParallelCluster is a very cool trick. So today, one of our illustrious solution architects and all-round Res expert, Doug Morand, is going to show us how this works and explain to us how to put all the right things in place to pull it off easily. Let's get into it.
Exactly, yeah. So you can pre-bake the ParallelCluster login node into one of the Res virtual desktops, and you can also package it with any additional software that you might want to leverage as part of working with the ParallelCluster. So if there's additional tools, Jupyter notebooks, other types of solutions that you might use, you can bake that into a virtual desktop that you can then provision out for any of your end users. Right, and the benefit here too is that because each of your end users have their own login node, you don't run into any of those situations where you could potentially have an end user that runs something, could be malicious, it could be unintentional, but something that could potentially take down one of your login nodes.
Doug's being too polite. Let me translate. If one of your users is occasionally a bonehead and runs something obscene on their login node that trashes the CPU and causes the system to seize up, well, the blast radius of that is now just them, no one else. That's karma. This is going to be a very attractive feature to system administrators just because of that. Anyway, enough with the gloating. Let's see this thing.
Yeah, so first thing, I will log into one of my environments. So I'll log in with one of my researcher accounts. I have access to spin up different virtual desktops. So here I can launch a new virtual desktop, provide a name. We'll select a project that has the associated software stack. So I have a login node for my 3.8.0 cluster. So this is integrated with my ParallelCluster version 3.8. Pick a desktop size. So here's where you get that flexibility where your end users can really create any type of virtual desktop size that they require. So we can create different software stacks which have this capability baked into it, and the end users can have different types of software install them. So we could have multiple software stacks here that actually have integration with ParallelCluster, all catered toward what's the end users need from a software and environment standpoint.
So if the end user was going to do like a heavy compiling session, they're going to be rebuilding, Atlas and PyTorch and all these other things that take, 7 days to compile. We could actually, the user could select for themselves a big, fat memory node instance to run their login node on and get a lot of work done quickly. And then, of course, turn it off when they're done. Fast CPU or a lot of CPUs when you need it, or maybe a GPU to do some fancy graphics because you're going to do some visualization on your data. All these things are good.
So we'll submit. And because I've created this login node as part of one of the newer capabilities that came as part of Res, which is the Res Ready AMI, you'll notice that this login node will actually provision fairly quickly, usually under around the 5-minute mark. So now that we have our virtual desktop provisioned, we can connect into it.
The fact that this happens inside a browser tab, and that we get a virtual desktop inside a browser tab, and that it's really, really responsive and it works really well, that never ceases to amaze people when I'm showing them Res. They think this is one of the coolest things.
Yeah, the response time, it's very snappy. So I can pull in my terminal. So I can run my sinfo commands. I can see that I can connect to my ParallelCluster here. So I can check the queue, see if anything is running. No jobs are running. I can create a job. Submit a job. Go back, check the queue. You can see that my job is now spinning up.
And now it's going to probably spin up some instances to support that job. And
Yep.
Hey, this is actually really cool. Now, Doug, that took like a few minutes to spin up an instance that you just conjured into existence from the Res console, from the user console in Res. You can turn this instance on and off, much like you can do with any other instance in Res. You can, suspend it as such and come back to it tomorrow. You can put a time box around this instance if you wanted to, and make sure that it's always awake 9 to 5 Mondays and Thursdays when you happen to be working in the lab, because Tuesdays, Wednesdays, and Fridays you have class. You could do all of the usual things that you can do, but this is instantly a portal into your cluster in exactly the same way that it would be if you're logged into your cluster, because you are.
Yeah, exactly. Yeah, I like to think of it as just the ability to integrate into ParallelCluster. I think of it as another component that I can add to my software stack. So if I have a list of software that I want to provide to an end user, I have it as essentially a checkbox to ask them during discovery of, do you need access to ParallelCluster? Yes or no? Then I add that component as part of their software stack, and I add that as part of the application build out for their virtual desktop environment.
If they were doing fluid dynamics, they could actually conjure up an instance, one of these login node instances in Res, with a graphical console on it, with a GPU inside the instance at the back, so they can run ParaViews, so that they can look at the fluid dynamic simulation around a vehicle or a wing or a turbine or whatever. They're just jumping in and getting straight to work. There is no messing around. So now the scoop, of course, is that we've got all the details of how to do this in a blog post, which is going to walk you through our recipe in our Git repo, the AWS HPC recipes library. What are the things that they need to consider when architecting their environment so that these two things can work together so nicely?
Yeah, I think from an installation standpoint, so what I recommend to the end users is that you typically start with your research and engineering studio installation, and so that will provision all of the underlying infrastructure that's required to run Res, and then in order to integrate with a parallel cluster, you want to also make sure that you provision your parallel cluster on the same underlying infrastructure that Res is deployed on. So from a networking standpoint, we want to ensure that parallel cluster has access to the same networking components, so subnets, VPCs, all of that information, so that we have that point-to-point communication with our parallel cluster.
The easiest way to do that, of course, would be if you were using the HPC recipe library. You can go to the HPC recipe library, you can spin up a network stack, which is going to give you a really nice networking environment for doing your HPC. Then you spin up your Res stack on top of that, or inside that networking environment. You also can spin up your parallel cluster recipe stack from one of those recipes, and you can get your parallel cluster environment. So all of that part's kind of easy so far. What about armies?
The way we look at this is to use the EC2 image builder. And so we start with what we use, the res-ready AMIs. And so there's components that essentially pre-bake the res bootstrapping process directly into our AMIs. And so think of that as a component. And another component we can add on top of the AMI is the ParallelCluster login node component as well. So when you're baking these AMIs for Res, we just add those components to the AMIs during the image builder process.
And that's it. Like we said, the details are all in the blog post here, and the process for implementing all of this is in the recipes library, which is where you can also find lots of other cheat sheets for getting stuff built quickly. You didn't actually want it to be hard, did you? Just checking. See you in the cloud.